Next, let's look at the other inverse functions. So you have inverse cotangent, inverse cosecant, and inverse secant. And they work very similar. So I'll let you guys look at the graphs on your own, and you'll see that each of them does initially fail the horizontal line test. So we always restrict the domains. And again, you just want to be careful with how each of them are restricted. For cotangent, we restrict the original cotangent function between 0 and pi. For the cosecant, so inverse cosecant, we restrict the original function basically between negative pi over 2 and pi over 2. Just remember that it would be undefined at 0 there because you do also have those vertical asymptotes in the cosecant and secant graphs. And then again, for secant inverse, looking at the original secant graph, we're restricting it between 0 and pi there as well. But again, we are jumping over pi over 2 because you do have those vertical asymptotes. So that's why the restrictions look a little bit different here, because again, you have those vertical asymptotes. So we're sort of jumping over parts of the graph there. Now, one thing you can do to answer these questions like we did in the other ones is to make tables. So I didn't make tables here. I'm going to show you a different strategy, but what you could always do is you could always make tables. And the big thing to remember whenever you're trying to answer things about cotangent, cosecant, and secant is to really use the reciprocal rules. So cotangent is the same thing as 1 over tangent. Cosecant is the same thing as 1 over sine. Secant is 1 over cosine. So one strategy for answering questions about exact values of these inverse functions is to make tables like I did already. So what you could do for each of the functions is you could just make a table. And remember that you can find your cotangent values by just taking 1 and dividing it by your tangent values, right? So you have a little bit of arithmetic to do there, but you can make tables. You just want to be careful because you have various domain restrictions, right? So those could be different than what are in the other tables. But you can create tables there as well. I'm going to do a different technique here, so that just to show you a different way to do it. And I'm going to use a unit circle. And we've seen unit circles before with plugging in the different points and where those points lie and all that stuff. So again, it's drawn, so bear with me. But I tried to draw my unit circle in here. And then what I did is I partitioned it into 4 and tried to put in those key angles and points. So, here's angle 0, which ends up at 0.10 on the end of the circle. Here's angle pi over 6, which ends up at √3 over 2, 1/2 at the end of the circle. Here's angle pi over 4, which on the circle would be √2 over 2, √2 over 2, and so on. And we can actually go ahead and use these to help us as well, instead of creating new tables. Now, one thing to note here, see if I can just write it in above. So for, and I'm going to just write it in shorthand here, inverse cosine, inverse cotangent, and inverse secant, excuse me, you're going to mainly use quadrants 1 and 2, and then for inverse sine, inverse tangent, and inverse cosecant, you're going to use quadrants 1 and 4. So for inverses, we actually don't need quadrant 3. If you look at all the domain restrictions we have of the original functions, they're either between negative pi over 2 and positive pi over 2 in general, or 0 and pi. So that's why I didn't fill in the third quadrant here, just because it's not really necessary for inverse functions. So that will just kind of help narrow things down a little bit. And we're also going to use the formulas for the circle just to help us. So remember that tangent was y over x when looking at those points. So for cotangent, it's x over y. Sine is always the y value of that point on the angle. So for cosecant, it's 1 over the y value. And cosine is always related to the x value. So secant would be 1 over the x value. So just kind of keep in mind how these reciprocals work. So let me show you how to use a circle. It does take a little bit of practice, but we can do it. So first thing I'm going to do is I'll do cotangent -1. Now, these are the hardest ones, right? If you have sine or cosine or tangent, tangent is still a little bit tricky because it's a ratio as well, but Sine and cosine are pretty straightforward because they're just the x and y values on the points as you go around the circle. These ones are tricky because we're using reciprocals here, so there's a little bit of arithmetic you have to think about first. So first thing I'm going to look at is cotangent. And I know that cotangent should focus on, quadrants 1 and 2. So we're just focused on this top half of the circle here. Now I want to remember that cotangent has that ratio of y over x. So you're dividing the x and the y values on those points. Now it's a little bit different here because I'm not plugging in the angle. I'm trying to figure out the point and then reverse back to the angle. So I need to think about, okay, well, what x over y would equal -1? That's my question, is which x and y value would equal -1 to get me that -1 value here. And again, I'm going to focus just on the first two quadrants. So I have a little bit of work to do. I have to think about, okay, well, when I divide those x and y's, what would give me -1? For instance, if I did 0 and 1, 0 divided by 1 is 0. That doesn't work, right? So if I go around the circle, the one that's going to work here is this pair. And that's because, and this isn't my answer, I'm just going to do some little work in pink here. If I do -√2 over 2 divided by -√2 over, +√2 over 2, well, √2 over 2, √2 over 2 just cancels, right? That would be just 1. So I do get -1 there. So that is the correct pair that gives me that ratio. And then I look out to my angle. My angle is 3 pi over 4. Okay, so that would be my answer here. It does take some practice to use the unit circle, but sometimes it's nicer because you don't have to have all these tables written out. You could just have your unit circle written out and use that. But you want to do whatever works for you. If you would want to make your own tables here, you can make your own tables as well. Let me do cosecant next. So for cosecant, you're looking in quadrants 1 and 4. So I'm looking on this side of the graph. My value is -2. So I'm asking myself, okay, well, cosecant is 1 over sine. So it's 1 over y. So I'm saying, okay, well, what 1 over y value would equal -2? And again, I'm looking only in the first and fourth quadrants. Well, the one that works there is this -1/2, right? If I think about that, 1 over -1/2, I'd multiply that by -2 over 1, and I get -2. So here was the y value that I was looking at. I reverse out to the angle, and that would be my answer here, -pi over 6. Now, I know the angles are written in their negative form here, and that's because with our restrictions, we are allowing some of them to be -pi over 2 to +pi over 2. We're not kind of writing the larger values instead, or they look larger, I guess, when we don't write them in the negative. So that's why you see the negative use down here. And then let's do one more. I'm going to use a different color here. I'll use purple. So we're going to do secant. So secant is 1 over cosine, which would be 1 over the x value of the point. So we're asking ourselves here, well, 1 over what x value would equal -2√3 over 3. And I'm doing secant here. So I should be using quadrants 1 and 2. So I'm looking just at the top half now. I'm saying, well, 1 divided by what would give me this? And again, I'm looking at just the x's. So I do need something negative. So if I want negative x's, I'm going to be on this side here. And I need something that has 3's and 2's in it. And the one that's going to work as my best guess, and you can check this, is this one here. So it's this one right here. 1 over -√3 over 2. You'd multiply by 2 over √3, negative. And you have -2 over √3 here. And I'm running out a bit of room, but when you rationalize that denominator, you do get this value here. You would multiply both by √3 over 3, and it would check out to be this. So that is the right value, and I go out to the angle, because again, I want the inverse, so I actually want the angle answer instead. So 5 pi over 6. So there's just a different way to do it. That's how you can do it, again, using the unit circle instead. And you can try it even with some of the values that we already did, right? So if I go back to my first problem in my last video, I was doing inverse of sine. Let's say I didn't have my table with me, I just had a unit circle. Again, for sine, you're using the first and fourth quadrant, so you're using these two. And sine relates to the y value. So I would look for this y value here, that's root 2 over 2, and I see it right there. And the angle was pi over 4, which is exactly what we had. When I did the other one, I was looking at a y value of -1/2, and -1/2 is down here, and the angle was -pi over 6, and that was the angle that I got here. So you can also use that unit circle if you like it better to find the exact value of all of the inverse trig functions. So just two strategies you can use. And again, if you don't like this, then I encourage you to make your own tables. You can do it yourself by just using the ratios here, even, or using the inverse reciprocal functions there. A little bit of arithmetic, and you can have your own tables as well. And then you just have that quick reference guide, and it will make answering the questions go much faster. One last thing I want to show you in this video before we sign off for a second in this video is you do have graphs as well. So I'm just going to use the book here and just show you quickly what those look like. But again, you can see these in your own text, so you could even Google them. So I didn't draw these graphs by hand, but these are the graphs of your inverse functions. So this is what they actually look like if you graph them, again, over those restricted domain and ranges there. So this is what your inverse sine function looks like, your inverse cosine, inverse tangent, inverse cotangent, inverse cosecant, and inverse secant. So they do have graphs as well. And again, they typically have restricted domains and ranges based on the original functions being restricted to get those, to get them to pass the horizontal line test.